Boeing has built 8 airliners that changed how the world moves. One started the jet age. One made flying affordable for ordinary people. One killed off 4 engine planes almost completely. And one sold more units than any aircraft in history. Here's every one of them. And the specific problem each was built to solve. Boeing 707. In 1958, crossing the Atlantic meant hours strapped inside a propeller-driven aircraft. Loud, slow, exhausting. The Boeing 707 ended that. It was the first commercially successful jet-powered passenger aircraft, and it made long-distance travel feel fast for the first time in history. Pan American launched the first transatlantic Boeing 707 service in October 1958 and cut crossing times dramatically. The aircraft carried around 140 to 180 passengers, depending on layout, cruised at roughly 600 miles per hour, and had enough range to make non-stop intercontinental flights genuinely practical rather than theoretical. The jet age started here, and Boeing is the company that started it. Boeing 727. The Boeing 707 proved Boeing could handle long international routes. Shorter domestic ones were a completely different challenge. Smaller cities had shorter runways and far less airport infrastructure. Many couldn't handle a jet at all. The Boeing 727, which entered service in 1964, was built specifically for them. Its solution was 3 engines mounted at the rear of the fuselage instead of under the wings. That kept the wings clean, which let Boeing fit powerful high-lift devices onto them. The result was an aircraft that could make steep approaches into short runways that would have been impossible otherwise. It was loud by any modern standard. Airlines didn't care because nothing else could reach the airports it could. Over 1,800 were eventually built, an extraordinary number for the time. Boeing 737. No aircraft in history has sold more. It first flew in 1967 and entered service in 1968, designed as a short to medium range aircraft that airlines could operate cheaply on high frequency routes. It was smaller than the Boeing 707 and Boeing 727, simpler to maintain and cheaper to run. That combination made it instantly attractive to any airline wanting to expand its network without spending enormous money doing it. Then it never stopped evolving. The original Boeing 737-100 became the 200, then the 300, 400, and 500. The next generation series arrived in the 1990s. The MAX series came in the 2010s. Each generation brought new engines, updated cockpit systems, and better fuel efficiency while keeping the fundamental design intact. That's the reason more Boeing 737s are flying around the world today than any other commercial aircraft. Boeing 747. If the Boeing 737 is Boeing's most successful aircraft, the Boeing 747 is its most famous. When it entered service with Pan American in January 1970, nothing like it had ever flown commercially. Nearly 70 meters long, carrying over 400 passengers in a normal layout and up to 600 packed in. Its defining feature was the upper deck, that hump sitting behind the cockpit, which gave the aircraft a silhouette anyone could recognize instantly. But the important thing the Boeing 747 did wasn't about glamour. By spreading operating costs across far more passengers per flight, it drove ticket prices down significantly. International travel stopped being reserved for the wealthy and became something ordinary families could actually afford. It served as the backbone of international aviation for decades. A handful remain in limited service today, though most airlines retired it in favor of more efficient twin-engine aircraft. Boeing 757. By the late 1970s, the oil crises had turned fuel costs into a serious problem for airlines. They needed something efficient. The Boeing 757 entered service in 1983 as the answer. A narrow-body single-aisle aircraft, typically seating around 200 passengers, but with a surprisingly long range for its size. It used 2 of the most fuel-efficient engines available at the time, letting it fly routes that previously demanded larger and far more expensive aircraft. Airlines put it on transatlantic routes, transcontinental services, and busy short-haul operations. Pilots loved it for a specific reason. It had more thrust relative to its weight, than almost any commercial aircraft of its era, giving it a climb rate that was genuinely impressive to fly. Production ended in 2004, but airlines kept operating it heavily long afterward, well into the 2000s and beyond. Boeing 767. Entering service in 1982, the Boeing 767 filled a different gap. Where the Boeing 757 was narrow and built for efficiency on medium routes, the Boeing 767 was a wide-body twin-aisle aircraft carrying more passengers over longer distances. Its real significance was a certification. The Boeing 767 was the first Boeing aircraft certified for ETOPS, meaning extended range twin-engine operations. That allowed it to fly long overwater routes, which previously required 3 or 4 engines for safety. That single change reshaped aviation permanently. Airlines no longer needed expensive 4-engine jets to cross the Atlantic. A twin-engine wide-body could do the same job more cheaply and just as safely. The Boeing 767 quietly made modern transatlantic travel affordable running routes between North America and Europe at a fraction of what earlier aircraft cost. It stayed in production for decades and still serves as the basis for the KC-46 tanker used by the US military. Boeing 777. When Boeing launched the 777 in 1995, it was the largest twin-engine commercial aircraft ever built. Everything about it was designed around size, range, and efficiency. It could carry between 300 and 400 passengers and fly non-stop between almost any 2 cities on Earth using only 2 engines. A generation earlier, airlines would have called that impossible. It was also the first commercial aircraft designed entirely on computers with no physical mock-up ever constructed. That mattered more than it sounds. Designing digitally let Boeing bring airlines directly into the process, incorporating feedback from launch customers like United Airlines before a single part was manufactured. The aircraft that came out the other end was one operators found unusually practical to fly and maintain. It became the default choice for long-haul international routes and remains one of the most widely operated wide bodies in the world, with the 777X variant carrying the lineage into a new generation. Boeing 787 Dreamliner. When the Boeing 787 entered service with All Nippon Airways in 2011, it was the biggest technological leap in commercial aviation in decades. The change was in what it was made of. Around 50% of the Boeing 787's primary structure, including the fuselage and wings, is carbon fiber composite instead of aluminum. That cut the aircraft's weight dramatically, which cut fuel consumption by roughly 20% compared to similar aircraft of the previous generation. The composite structure unlocked something else too. Aluminium corrodes when exposed to moisture, which forces airlines to keep cabin air extremely dry. Composite doesn't have that problem, so Boeing could raise cabin humidity and lower the effective cabin altitude to the equivalent of 6,000 feet instead of the usual 8,000. For anyone on a long flight, the difference is real. Less dehydration, less fatigue, less of that wrecked feeling on arrival. Boeing also replaced physical window shades with electrochromic dimming, letting passengers darken the glass electronically. The program had a rough start with significant delays and a well-publicized battery problem early in service. Once those were solved, it became one of the most ordered aircraft in Boeing's history and permanently changed what passengers expect from a long-haul jet. Line them up and a pattern appears. Every one of these aircraft solved a specific problem that existed at the time. The Boeing 707 solved speed. The Boeing 727 solved small airports. The Boeing 737 solved cost. The Boeing 747 solved capacity and made flying affordable in the process. The Boeing 757 solved fuel efficiency in a narrow body. The Boeing 767 solved the ocean, proving 2 engines were enough. The 777 solved size on 2 engines. The Boeing 787 solved weight itself by changing the material planes are built from. Each one made the next one possible. Without the Boeing 767 proving twin-engine aircraft could safely cross oceans, there is no 777. Without the 777 proving big twins worked commercially, there's no reason to build the Boeing 787. And without the Boeing 787 proving composites could work at scale, the 777X wouldn't exist. Whatever Boeing builds next has to solve a problem nobody has cracked yet. That's the only reason any of these aircraft ever got built.